Okay, so we begin with multiplication of matrices. But let me take you back and let's compare our solution to the last assignment I gave you. Let's check the question and the solution. Yeah, so you were given this as your assignment when matrix G is 2, 3, 1, 4, neg 3, 2, 1, 7, neg 11, and matrix H is 4G. Find G plus 3H. So with this, let's look at the solution. Solution, we have the matrix H, and to obtain your H, they said you should multiply the whole matrix G by 4. So this is the 4 multiplying the 4 here, multiplying the G, and that is 4 times the whole of matrix G. This is the whole of matrix G. Now, so that if you multiply 4 by -2, it gives you -8. 4 by 3 is 12. 4 by 1 will also give you this 4. 4 by 4 will give you the 16 here. 4 by neg 3, neg 12. 4 by 2, you get 8. If you do everything in that order, you get the matrix H to be -8, 12, 4, 16, neg 12, 8, 4, 28, neg 44. So we move on to the next thing, which says G plus 3H. So we are going to multiply the matrix H by 3. Then we add it to the matrix G. And that gives us the matrix G, which we know was given earlier on, plus the whole of this matrix G is here, plus 3 multiplying H. Our H we calculated for earlier on is also here. We are multiplying the whole of this matrix now by 3, so that if we do whatever is in the bracket there first, and that is going to give us the first matrix, which is G. If you multiply the previous matrix by this, the whole of matrix H by 3, it is also going to give us neg 24, 36, 12, 48, neg 36, 24, 12, 84, negative 132. Now we are adding the two matrices here. So we know that the addition rule, we add their corresponding component. So by adding corresponding component, we will now have the matrix below, which is -26. That's -2 plus neg 24 will give you -26. 3 times 36, 3 plus 36 will also give you 39. 1 plus 12 will also give you the 13. So if you go through the same process, you arrive at the matrix here as your final answer. And we marked this, we scored this 10, 10 marks. So if you had 10 marks, yes, you've done very well. And let's keep it up. Let's move to multiplication of matrices. So multiplication of a 2 by 2 matrix by a 2 by 2 matrix, which means, okay, there is a hand up. So Theophilus,
Say,
yeah.
the question that you sent to the Google Classroom, it was 2 questions. Actually, the one that I just saw with the second one.
Or really?
Yes, sir.
Okay, I will recheck it again.
And I did what you just did, but I gave me 9.
Oh, it seems your final answer was wrong. Can you check it
No,
again?
it's right.
Okay,
Say it's right. The paper is just here.
I will check it and then get back to you.
All
I,
right.
all right. So let's continue with this. After this lesson, I will recheck it and then uh, do justice to that. Now, multiplication of a 2 by 2 matrix by another 2 by 2 matrix. When you have one matrix which is 2 by 2, multiplying another matrix 2 by 2, let's see the steps we need to go through in order to arrive at the appropriate solution. So two matrices P and Q can be multiplied if and only if they have the same size. So when they have the same size, that is the number of rows and the number of columns. That is the number of rows is equal to the number of columns. So that is it must be equal matrix. Hence, they are said to be compactable. So if you have two matrices which involves multiplication and they all have equal number of rows and equal number of columns, we say that those two matrices are compatible. For example, if P equal to A, B, C, D, Q equal to E, F, G, H, then we can have this. PQ. PQ means P, the matrix P times the matrix Q. So the matrix P is given as A, B, C, D, multiplying the matrix Q, which is E, F, G, H. So now, this is how we do the multiplication. First, the first row will multiply the first column. So if I pick this, this is the first row, and it is going to multiply the first column in the second matrix. The first row multiplies, this is the first column. So that your A times E will give you AE, plus your B will also multiply G, and that will give you BG. Again, your first row will also multiply the second column. So A times F will give you AF, plus B times H will also give you BH. Let's go to the second row. The second row we have there is CD. So if you have CD, this is also going to multiply the first row and the second row in the second matrix. So C times E will give us CE, plus D times G will give us DG. C times F will give you CF, plus D times H will give you DH. If you continue, so yes, that will give you your solution. What it means is that if you multiply a 2 by 2 matrix by another 2 by 2 matrix, your final result will be a 2 by 2 square matrix. Let's pick an example to this. The first example, given that the matrix A equal to 3, 4, 2, 1, and the matrix B equal 1, 2, 1, 2, evaluate AB, BA, A squared, and B squared. Let's solve the first one together. So solving the first one, we go to solution. AB, which means we are multiplying the first matrix by the second matrix. So 3, 4, 2, 1, multiplying 1, 2, 1, 2. this is equal to, so 3 times, so which means that the first row is the 3, 4. So if you pick the 3, 4, the whole of this row is going to multiply the whole of the first column. So 3 times 1 will give us 3, plus 4 times 1 will also give us 4. Now, the first row again will multiply the second column, which is the 2, 2 here. So 3 times 2 will give us 6, plus 4 times 2 is also 8. It's supposed to be 8. 4 times 2 would give us 8. Let me check that quickly. Three times 2 will give us 6. 4 by 2 will give us 8. So we have 8 instead of 4. And this will give us 14. Good. Okay. Let's go through that process. Yes. So 4, that's 3 by 1 is 3. 4 by 1 is 4. 3 by 2 will give you 6. 4 by 2 is also 8. So you do the same thing to the second row. 2 by 1 is 2. 1 by 1 is also 1. 2 by 2 is 4. 1 by 2 is 2. So if you add everything, then we have 3 plus 4, now 7. 6 plus 8, 14. And then 2 by plus 1 will give us 3. 4 plus 2 will also give us 6. So that is the solution to the first part. Do you all understand this?
Yes, sir.
Okay. Please copy the question. So that is the question, please. Just do the BA. Everybody should do the BA. If you are done, you can raise your hand. Yes, rejoice.
7676.
Okay, that's your answer. Um, I saw another hand up. Theophilus.
7676.
Okay. Ewoyi.
7676.
Okay. So let's check the suggested solution. So the first thing, BA. So we have the two matrices. If you multiply, you get the values 3 plus 4, 4 plus 2, 3 plus 2, 4 plus 1. It's supposed to be 4 plus 2, right? 4 plus 2. So that, so we have 4 plus 2 here. And that will give us, so we have 1 times 3, which is 3. 2 by 2 will also give us 4. 1 by 3 will give us 3. 2 by 2 is also 4. So we have 4 here. So that if you multiply 1 by 4, we have 4. 2 by 1, it also gives us 2. So your final answer will now be 7676. That's right. 7676. Is that clear? Can you all see that?
Yes, sir.
All right. Now, the next one. Okay, so that's what we have there. The next one will be a squared, and we know that our a squared is the same as a times a. So a times a, which means the matrix A will multiply itself. So we have 3, 4, 2, 1, 3, 4, 2, 1. And if you solve everything, this will also give you 12, 16, and then 8, 9. Did you all get that?
No, sir.
What did you get?
No.
17, 16, 8, 9.
Come again.
17, 16, 8, 9.
Did you all get 17, 16, 8, 9?
Yes.
Okay. So there may be a typo here. So let's do it together and see. So 3 times 3 will give us 9, plus 4 times 2 is also 8. So yes, the 3 here is supposed to be 8. So your answer is correct. Who is not following what we are doing, please? Who is not following? Benoni, are you following? Amema Chokarage, are you following?
Yes, sir.
Okay. Dogbe Roslyn, are you following?
Yes, sir.
Nukunu, are you there? Awaga, is everything okay?
Yes, sir.
Okay. All right. Now let's move to the next one. Example number 2. Given that A equal to negative 1, 2, negative 2, 4, B equal 1, 0, 2, 0, and C equal to negative 4, 2, neg 2, 1. Evaluate AB, AC, CB, and B squared. Try the first one, everybody. I will call you to give me your answer. So you copy the question, you solve it after that. Yes, who is done? Joshua and to me.
Sir.
Yes. Your answer, please.
Sir, please. Sir, please, I've not solved it.
Okay. Kuma Jasper.
Service, I'm not done.
Okay, Theophilus. Theophilus, your hand is up.
Yeah, I had a 3060.
Okay, that's your answer. Ewayi.
3060.
Okay, let's consider the suggested solution. So for the first one, our solution is this. So AB will give us negative 1, 2, neg 2, 4, multiplying 1, 0, 2, 0. This will give us, so negative 1 times 1 will give us negative 1. 2 times 2 will also give us plus 4. Negative 1 times 0 is 0. 2 times 0 is also 0. Then we come to the second row. Negative 2 by 1 will give us negative 2 plus 4 times 2 will give us 8. Then again, negative 2 by 0 will give us 0 plus 4 times 0 is also 0. Now, if you do the addition, we have 3060. Theophilus, your hand is up. Ewa, your hand is up.
Yes,
Okay.
sir.
All right. So did you all get that answer?
Yes.
Dogbe Roslyn, did you get that answer? Okay. Nukunu Frank, are you following what we are doing?
Yes, sir.
Okay. Did you get the same answer? Did you get the same answer?
Yes, sir.
Okay. Now do the second one. Everybody should do the second one for me. The second one, AC. A lot of hands are up. Um, Kuma Jasper.
Please, I had 0003.
Okay. Togbe Roslyn.
Sir, please, I also at 0000.
0000.
Yeah.
Okay. Let's check the solution to that. So our solution is this: AC equal to the matrix A multiplying the matrix C. So if you do the multiplication, we have 4 minus 4, negative 2, 2, 8 minus 8, negative 4 plus 4. And that will give you 0, 0, 0, 0. So that is the matrix AC. So you will see that if you multiply a square matrix by another square matrix, the answer will be a square matrix. Is that clear to everybody?
Yes.
Okay, so you can go ahead to try the rest. We have the solution there, but just go and try them on your own. Let's pick example number 3. Example number 3. Given that the matrix M equal to 2, 4, 1, negative 3, and the matrix N equal to negative 1, 1, 2, 3, find NM, MN, and NM. Please, Dogbe, can you do justice to that? Find MN and NM. Try that quickly. Let's see. You try the first one, which is MN.
Say the question again.
Can you see the screen?
No, sir.
So example number 3, given that M equal to 2, 4, 1, negative 3, and N equal to negative 1, 1, 2, 3. Find MN and NM multiplication. So multiply your M by N and then your N by M. Yeah, a lot of hands up. Let me see those hands. Okay, hold on, I'm coming. You have some few seconds to complete that, after which we shall all look at the suggested solution here. Okay, Theophilus, can you give us your answer?
Yes, sir. I had 6, 14, -7, -8.
Okay, that's your answer. Ewoy,
6, 14, -7, -8.
okay, thank you. Bisanana Kofi,
Service and the answer to be 6, 14, -7, -8.
okay. I'm a macho courage.
Say I had 6, 14, -7, -8.
Okay. All right. Nukunu Frank.
So I had 6, 14, -7, -8.
Okay. And last person, Chantal.
Sir, I had 6, 14, -7, -8.
Okay, so it's like everybody is getting the same answer to the question. So we can take it from there. Yeah, so our solution is this. You go through the process, 6, 14, -7, -8, like you said. Okay, Dogbe, your hand is up.
Sir, please, I want to answer the NM.
Okay, give us your answer.
Hello, sir. -1, -7, 7, -1.
Class, did you all get that same answer?
Yes, sir.
Yes, sir.
All right, thank you. That's good. Excellent. Let's move to the next slide. So yes, that's the solution there. Another example, we have example 4. Just do this quickly, let's see. Let me call someone to give us the answer. Awaga Cromwell, you will give us the answer to this problem. Awaga. There is I can see your hand, but hold on. Awaga should give us the answer. Okay, Theophilus, give us the answer.
Sir, 7, 1, -6, -4.
Okay, let's check the solution and see. So our solution, if you go through the solution, we have 7, 1, -6, -4. Did you all get that?
Yes, sir.
You are saying yes, sir, but you didn't raise your hand. Okay, so example 5, please just copy it. Just copy it and go and try it so that we move on. Copy example number 5. Given that the matrix A equal to 2, 1, 3, -2, and matrix B equal 4, -2, -1, 3. Find BA and AB. So you go and try this. That is for multiplication of square matrix by another square matrix, specifically 2 by 2 matrix. So let's go to multiplication of a matrix by a vector. How we can multiply a given square matrix by a vector. The method is the same as multiplying a 2 by 2 square matrix by another 2 by 2 square by a vector. So it shouldn't be by another 2 by 2 square matrix. The method is the same as multiplying a 2 by 2 square matrix by another 2 by 2 square matrix. Yes, that is true. So we go through the same method and we arrive at the solution. Write that quickly, please. For example, given the matrix P equal to STUV and Q equal to MN. So you will see that the first matrix is a square matrix and the matrix Q is also a column matrix. This is the same as a 2 by 1 matrix. 2 by 1 matrix. So let's see how we can do the multiplication. PQ will now give us the matrix XTUV multiplying the vector MN. This is equal to, so your S will multiply M to give you SM. Your T will multiply N to give you plus TN. U multiplies M to give us UM plus V multiply N to give us Vn. That is your final answer. So if you multiply a square matrix by a column matrix, your answer will be a column matrix or a vector. Let me take it again. When you multiply a 2 by 2 matrix by a column matrix or a vector, your answer will be a vector. Let's pick an example. So hence, when a matrix is multiplied by a vector, the result is a vector. That's all. When a matrix is multiplied by a vector, the result is a vector. Write this quickly. Any problem? Chantal, do you have any problem with this?
No, sir.
Okay. Have you finished copying?
Yes, please.
Okay. Nukunu Frank, are you done copying?
Yes, sir.
Okay. Let's pick the first example there, or we go to the next slide. Yes, example 1. If D equal to 5, 2, 4, 3, and C equal to the vector 3, 2, find DC. Our solution is this. DC will be equal to the matrix D multiplying the vector C. So we have 5 times 3 plus negative 2 times the 2. That will give us this. Again, we have 4 by 3, this, plus your 3 by 2. So if you continue, 5 times 3 will give you 15. Negative 2 times 2 will give you negative 4. And then 4 by 3 is also 12, plus 3 times 2 also gives you 6. So if your final answer will be 11, 18. So you see that anytime you multiply a square matrix by a given vector, your answer is a vector. Any problem? Copy this. Nukunu Frank, have you finished?
Yes, sir.
Okay. Waga, are you done?
Yes, sir.
Okay. Let's go to the next slide. Example 2. Given that A equal to 4, 5, 6, 7, and B equal to the vector 1, 2, find AB. Everybody should try that. Kudoda Queen, you will give us the answer to this problem. Yes, Queen. Okay, Awaga, your hand is up.
Sir, 14, 20.
It's like your network is not good. Your network is bad. Can you come again?
Sir, 14, 20.
Okay, 14, 20. Ewa, give us your answer.
14, 20.
Okay. Queen, are you ready with your answer? Benoni. Kumi Monica.
The 14, 20.
Okay. So you are all getting the same answer. Let's look at the solution. So we have, so 4 by 1 will give us 4 times 1. 5 times 2 will also give us this. 6 times 1 is this. Okay. So there is a typo here. 6 times 1 is supposed to be 6. So 6 times 1, there's instead of 5, it should be 1. Then 7 times 2 is also 14. So that this times this, we get 4. 5 times 2 is 10. This is 6 times 1, so it's supposed to be 6. And that will give us 14, 20. 14, 20, not 14, 44. Okay. 14, 20. The third example. Now we have the matrix. Given that the first matrix, which is a square matrix, 4m, 5, 6n, multiplying a vector 1, 3 equal to 23, 8. Find the values of m and n. So this is just very simple. You'll see we have 3 matrices there. We multiply the left side, we do the multiplication there to get another matrix. Whatever we get, we can now compare left and right by equality of matrices. So let's try solving this. Our solution is this. So we have the given matrix. So if you do the multiplication, we have 4m times 1 giving us this, plus 5 times 3 will also give us this. Again, we have 6 times 1 giving us this. Then n times 3 will also give us this expression. This is the same as, so if you simplify both sides, you see that 4m times 1 will give you 4m plus 5 times 3 is also 15. 6 times 1 will give you 6, plus n times 3 is 3n, equal to the vector, which is 23, 8. Now, by equality of matrices, we can say that your 4m plus 15 equal to 23, so that your 4m will now be equal to 23 minus 15, and that gives you 4m equal to 8. Since we want to solve for m, we divide through by 4, and that will give us our m equal to 2. Now, we can also say that 6 plus 3n equal to 8, so that your 3n will now be equal to 8 minus 6, that is by grouping like terms. And your 3n will now be equal to 2. We want to solve for n, so our n, we divide through both sides by the coefficient of n, which is 3. So 3n divided by 3 equal to 2 divided by 3, and that gives us our n equal to 3. So your final answer, your conclusion, we have our m equal to 2 and n equal to 2 over 3. Let me just go back quickly so that you can copy this. Who is having any problem with this solution? If you have any problem with the solution. Chantal,
Yeah.
is it okay?
Yes.
Okay. Rejoice, is it okay?
Yes.
Ibo Maxwell, did you get it?
Yes, sir.
All right. Nukuno, have you finished copying the first page here?
Yes, please.
Okay. So we move to the second page. Okay. Do that quickly. Awaga, can we continue?
Yes, sir.
Okay. Determinant of a 2 by 2 matrix. We want to find the determinant of a matrix. Now, when you have a square matrix, in this case 2 by 2, given the square matrix Q equal to PQRS, the determinant is given by this. So we use this symbol to denote determinant. If I use this symbol, that represents the determinant. Or we can also use DET, that's also the short form of a determinant. So you can use any of them. So the determinant is given by this. So you see, we are no more using the bracket, but we are using the symbol here. And that tells you that you are finding the determinant of the given matrix Q. So this is equal to, what we do is this, we multiply the diagonals, which is PS. So P times S will now give us PS, minus Q times R will also give us QR. That's all. That is how to find the determinant of a given square matrix, 2 by 2 in this case. Example, if A equal to 7524, then now let's find the determinant. So determinant of place is supposed to be A. Determinant of A will be equal to 7524. Now we do the multiplication. If you do the multiplication, determinant of A is given by that, so that 7 times 4 will give us this. 5 times 2 will also give us this. So we have 7 times 4 minus 5 times 2. And that gives us 7 times 4 is 28 minus 5 times 2 is also 10. So your determinant is 18. Frank, are we there? Okay, to me, Joshua, your hand is up.
Sir, please, is it always that we must subtract or sometimes you add?
You subtract. We don't add.
Okay.
You only subtract. But take note, if any of the numbers there is negative, then negative is likely to be positive. Are you okay?
Yes, sir.
Especially if any of the values 2 and 5 there, any of them is negative, then it's going to be 5 times that negative number, and that will be negative, so we get positive. Are you okay?
Yes, sir.
Yeah. So you will not always see the subtraction sign here. Sometimes it may be positive when it comes to this place. Is that clear?
Yes, sir.
But take note, your determinant could also be a negative value. It's not always a positive value, depending on the given values. Okay, let's take another one. Also, if the matrix K equal to 1, 12, 3, 5, then det K, we call this det K, that's determinant of K, will be equal to determinant of 1 to 12, 3, 5. That will give us 5 times 1 or 1 times 5 minus the 12 times 3. So we get 5 minus 36. And 5 minus 36 will now give us negative 31. That is the determinant of the matrix K. Rejoice, are you okay?
Yes.
Okay. Awaga, did you get it?
Yes, sir.
Okay. Jasper, are you following what we are doing?
Yes, sir.
Okay. Have you finished copying this?
Yes, sir.
Let's continue. Now you will try this for me. Everybody should try that. Okay. Ewoy.
Negative 10.
Okay, that's your answer. Joshua.
Negative 10.
Okay. Nana Kofi.
Sir, please add negative 14.
You had negative 14. Okay.
Yes.
Okay, that's your answer. Who again? Awaga.
The negative 10.
Okay. Kudo da Queen, the last person.
-14.
Let's try that and see. Let's check our solution. So that 4 neg 2, 1 neg 3. This will give us 4 multiplying -3 minus this is supposed to be 1. So we have 1 multiplying -2. So that you get 4 multiplying this will give you -12 plus 2. -12 plus 2 will give you -10. Your answer will be -10. The value here is supposed to be +1 because there is 1 here. So this times this will give you -12 minus this times this is also -2. So -12 plus 2 will now give you -10. That's the solution. So please you check it. Nana Kofi, are you okay?
Yes, please, yes, I've seen a mistake. Yeah.
All right, okay.
Thank you.
Who also gave the wrong answer? Have you also seen your mistake?
Yes, sir.
Okay, all right. So we move to determinant of a 3 by 3 matrix. Knowing how to find the determinant of a 2 by 2 square matrix, we want to find the determinant of a 3 by 3 matrix. So given the square matrix Q equal to A, B, C, D, E, F, G, H, I, this is a 3 by 3 square matrix. In the form Q equal to plus minus, plus minus, plus minus, plus minus, plus. That is the order in which it must be. Take note of that. Plus minus, plus minus, plus minus, plus minus, plus. That is the order of a given 3 by 3 square matrix. Now, the determinant of this is given by, let's see the determinant. Now, that Q equal to the whole of this. So you see, if I bring this symbol, meaning we are finding the determinant of the matrix. This is equal to, so now, to find that Q, you go to the first row, first column. The first row, first column there, we have the first element there is A. So you go and pick A. Now, if you pick A, you are going to cancel that first row, you cancel the first column. Now, all the elements remaining, the ones you didn't cancel, we call them cofactors. So, let me do that. If I pick A, to get the cofactors of A, we will now do this. I'm going to take off the whole row and then the whole column. Now we are left with EF, HI, and that gives you the cofactors of A. Frank, did you follow that?
Yes, sir.
Good. Now, if you remember, we said that the second letter, the B there is negative. So I'll say minus B. Now, if I pick this B, which is first row, second column, let me go and then do that. First row, second column. We are picking B. I can pick that now. I'll pick my B here. Oh. Okay, so I'll pick my B. Now, if I pick my B, then again, I'm going to cancel, since B is in the first row, I'll cancel the whole of the first row. So I'll clear the first row. Again, it is in the second column, so I will remove the whole of the second column. Now we are left with DFGI. That gives me the cofactors of P, or for B. Again, we pick the C. C is in the first row, third column. So let me clean this. We go there and pick. Let me pick my pen so that we can get our C. Let me pick my C in the red ink. That's first row, third column, which means that we are going to cancel the whole of the first row and then the whole of the third column. So now we are left with DEGH. That is what we have here, the cofactors for C. That's all. Now, if you know all this, you know you are just going to find the determinant of EF, HI, determinant of DF, GI, determinant of DE, GH. Again, you can also take it in any form. You can also find the determinant using any other method again. Let's see which ones we can use. Alternatively, if you have the matrix Q, then the determinant of Q will be this. So we can also have this, but don't forget the order. That's the plus, minus, plus, minus, plus, minus, plus, minus, plus. You shouldn't forget that order. So now, if I pick the A, so I'm just going to use the first time I started using the row. Now I'm going to pick the first column. So in the first column, I will pick A. So if I pick A, I will circle my A. Now, if I circle A, I'm going to cancel the whole row, the whole of the first column. And that will also give me this. So let me cancel the whole column, the whole row. Now you are left with EF, HI, minus, I'm picking the D. I told you I'm using a first column, so I'm going to pick the D now. And if I pick the D, don't forget that this D here is negative. So minus D. Now let's get the cofactors. So to get the cofactors, I'll select my D. Then I'll now cancel the whole of the second row and the first column. So you are now left with BC and HI. That gives me the cofactors here, plus the third one is G. If I pick G and I remove the first row and the third row, sorry, the first column and the third row, then we are now left with BCEF. That is another way of finding the determinant of a 3 by 3 square matrix. We now take some example. Let's pick an example and see how we go about it. The first example is this. Find the determinant of the following matrices. So we have some matrices here. I want you to copy them. Please copy these matrices. Awaga, did you write the explanations I gave earlier on? Awaga, did you write the formula I gave you earlier on? Kudo da Queen, did you write that?
Yes, sir.
Okay. Copy the examples here and let's solve them together. Ame Machokari, did you also write the formulas I gave you?
Yes, sir.
Okay. Okay, so let's go to the first one. We are going to solve the first one. Solution. Now we have the matrix D equal to that. So determinant, so I have to bring this. If you don't bring this symbol, then you are not finding the determinant of the matrix D. Now this is equal to, so as you can see, I picked the 2. If I pick the first 2 here, it means that I'm going to cancel the first row and the first column. So the cofactors 6, 3, 2, 5 minus 3. The next one is 3. If I pick the 3, again, I'll cancel the first row and the whole of the second column. So my cofactors will be 6, 3, 4, 5. Please, it's supposed to be 6, 3, 4, 5. Then the next one, I'll pick 4. If I pick 4, then I'll cancel the first row and the third column. So we are left with 6, 6, 4, 2. 6, 6, 4, 2. Please solve that and give me your answer. Yes, Theophilus.
Say negative 54.
Okay, that's your answer. Yes, who again? Let me see. Bisanana Kofi. Hawaii.
Negative 54.
Okay, negative 54. Please, did you all get that answer?
Yes, sir.
Okay.
Yes, sir.
All right. Negative 54. So please, you can copy that. But try and do the corrections. So if you go through the process, you'll get negative 54. Nukuno, did you get it?
Yes, please.
All right. So we go to the second one. Everybody should try the second one for me quickly. It's almost time. Try the second one quickly for me. There's a hand in Ensan.
Say, I had negative 24.
Okay. That's your answer. Benoni. Benoni. Ewai.
I had 0.
You had what?
0.
Okay. Now let's check our solution. So to find the matrix or that E, this is the solution. And if you go through all the steps, your final answer will be 0. Your final answer is 0. Any problem with this? Who is having any challenge here? Any difficulty in solving the determinant of a matrix? Okay, so if no problem, then I think we have to end our class here and continue next week, same time next week. Please, I want you to go through the notes I've given you. I'll be posting the notes, or I'll forward the notes to onto the Google Classroom so that you can have access to it. Any concern?